Hello, 8th graders. This is Mr. Humphreys, and we are headed back to Chapter 2. Now, real quickly before we go on, Chapter 2, we learned about inductive reasoning. Now, if you remember, an inductive reason was when you made a pattern, you did something. Inductive reasoning was the process of reasoning that a rule or statement is true because of specific cases that you can prove that are true. Now, in Section 2.3, we're going to use deductive reasoning to verify conjectures. So there's going to be inductive reasoning and deductive reasoning. Now, deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. So the next example I'm going to give you, it's a lot of words. You don't need to write it down. If you just want to make a note, it's in page 88 of your book. Example 1. Urban legends and modern myths spread quickly through the media. Many websites and television shows are dedicated to confirming or disproving such myths. Is each conclusion a result of inductive or deductive reasoning? So let's look at the first one. There is a myth that toilets and sinks drain in opposite directions in the southern and northern hemispheres. However, if you were to observe sinks draining in the two hemispheres, you would see that this myth is false. So, not sure if you knew this, but a lot of people think the equator, everything above the equator, water goes down the drain one way, and everything below the equator, water goes down the drain the other way. However, if you were to observe sinks draining into two hemispheres, you would see that this myth is false. I want to know if it's inductive or deductive reasoning. Now, inductive reasoning is by observing something, looking at patterns. Deductive reasoning is using logic to draw conclusions from facts, definitions, and properties. Well, if you are actually going to go and observe some toilets or sinks and flush them, that is a pattern. So because you're using a pattern, this conclusion, which is based on the pattern of observation, is a result of inductive reasoning. There is also a myth that you should not touch a baby bird that has fallen from its nest because the mother bird will disown the baby if she detects human scent. However, biologists have shown that birds cannot detect human scent. Therefore, the myth cannot be true. So, what would you base this on? Well, this conclusion is based on logical reasoning from scientific research. Therefore, this is deductive reasoning. Now, in deductive reasoning, if the given facts are true and you apply the correct logic, then the conclusion must be true. The law of detachment is one valid form of deductive reasoning. So this is a type of deductive reasoning. Here's what the law of detachment says. If P then Q is a true statement. So if P then Q is a true statement and then P is true, then Q is true. So let me say that again. If you have an if-then statement that is true, if P is true, then Q must also be true. So let's do some examples of that. Example 2. I want you to use the law of detachment to determine if each conjecture is valid. So let's look at A. We have a given. It says that if two segments are congruent, they have the same length. Now that's a given. So then we have segment AB is congruent to segment XY. The conjecture then would be that AB, the length of A to B, is equal to the length of A to Y, or X to Y. Now, let's look at the hypothesis and conclusion. So here's what we have to do. If the hypothesis and the conclusion are, if the entire thing is true, okay, if the entire thing is true, then we can go on. So if two segments are congruent, then they have the same length. Is that true? Yes, that is true. So segment AB is congruent to segment XY. That matches the hypothesis. So because the whole thing is true, hence the law of detachment, if we take the hypothesis only and say that's true, then the conjecture must also be true. So because segment AB and segment XY are congruent, that's the hypothesis. By law of detachment, we can say that the length of AB is equal to the length of XY. Therefore, this statement is valid. And the second part of this, B, given. If you are tardy 3 times, you must go to detention. Shay is in detention. Conjecture, Shay was tardy at least 3 times. So we're going to say, if you are tardy 3 times, you must go to detention. That's true. And it's true because it says it's true, since it's the given. So, Shay is in detention. But Shay is in detention does not match the hypothesis. It matches the conclusion. So, this entire thing is true. So, if P, then Q. That's the first part. And then it says, if P is true, but we don't have the hypothesis. This is backwards. Since Shay was tardy at least 3 times, that's the hypothesis. That doesn't mean it's true. So Shay could be in detention for another reason. This conclusion, this conjecture, is not valid. Another valid form of deductive reasoning is called the law of syllogism. It allows you to draw conclusions from 2 conditional statements when the conclusion of one is the hypothesis of another. So the law of syllogism states this: if P then Q, and if Q then R are true statements, then if P then R is a true statement. Notice that the conclusion of the first one and the hypothesis of the second one are true. They're the same thing. So because the hypothesis matches the conclusion, we can say P then R. So if the conclusion of one matches the hypothesis of another, we can then say if P then R. So let's put that together. Example number 3. Determine if each is true by the law of syllogism. So in A, we are given a given. It says if the measure of angle A is less than 90 degrees, then the angle A is acute. If angle A is acute, then it is not a right angle. So our conjecture would say if the measure of angle A is less than 90 degrees, then it is not a right angle. So if the measure of angle A is less than 90 degrees, that would be your P. Then the angle A is acute. That would be your Q. Since it's repeated, we have Q, and then we have an R. So because the hypothesis of the second one matches the conclusion of the first one, we can take P, then R, and make a statement from it. So this is true. So this is a valid reason, a valid conjecture, proved by the law of syllogism. In the second example of part 2, it says, determine if each conjecture is valid by the law of syllogism. So once again, here's our given. If a number is divisible by 4, then it is divisible by 2. If a number is even, then it is divisible by 2. So then we can say, if a number is divisible by 4, then it is even. So in this problem, we can let, for example, x, if we want to, be the hypothesis of the first one, and y be the conclusion of the first one. But then, notice that the conclusion of the first one is repeated in the conclusion of the second one, which you'll notice right here. It's the same thing. That is not true. Remember, if we had this, and then we repeated the conclusion as the hypothesis on the second one, then it'd be true. But the y's are in the wrong spot. This right here would have to be moved up to the hypothesis. So this is not valid. So now in our last example, we're going to apply the laws of deductive reasoning to make our own conclusion from the given information. So in A, given, if a team wins 10 games, then they play in the finals. If a team plays in the finals, then they travel to Boston. Notice that the conclusion in this first one matches the hypothesis in the second one. Therefore, we can state our conclusion: if a team wins 10 games, then they will travel to Boston. Because it says right here, the Ravens won 10 games, so our conclusion would be the Ravens would travel to Boston. The second one, if 2 angles form a linear pair, then they are adjacent. If 2 angles are adjacent, then they share a side. Angle 1 and angle 2 form a linear pair. So notice this right here. If they are adjacent, they are adjacent. It's the same thing. So we can just take the first one and the last one. Well, since angle 1 and angle 2 form a linear pair, that's a repeat of the first hypothesis. We can state that angle 1 and angle 2 share a side using the law of syllogism, which states if x then y and y then z, then we would know if x then z. The only vocab word from this section is deductive reasoning. Make sure though, however, you know what the law of detachment and the law of syllogism are.